We have this. What's next? What do you feel like is needed to be done?
Well, I would love for them to not just go away. I would love for them to,
Right. How do we do that?
well, you limit their distance that they can go, like clamp it.
Yeah, but what should they do when they reach these limits?
Like bounce.
Ooh, interesting. Good thinking.
Dang.
Let's do that then. So first we need to specify the bounds, right?
Mm-hmm.
And then the bounds we have are specified in this map. So
okay.
what I usually do is I promote this to variable, Unreal lingo. So I usually do
I'm
this.
triggered.
I mean, y max, z mean, z max. We had this. And now we're gonna reuse it here.
Nice.
And then here. And we're gonna add two more vectors.
Mm-hmm.
So it's gonna be u min bounds and u max bounds.
Mm-hmm.
And we're gonna export these guys here. And this and that and that. All right. Make sense?
Mm-hmm.
All right. So now we're gonna use it inside our shader. So first of all, our uniforms. All right, one thing that I want to show you is that, do you notice how they all move in positive direction?
Is it because of what I said before, where our velocity wasn't negative?
And when did you say this?
I said before, and you were like, stand by, that's a separate issue. And I said, okay.
Okay, yeah, well, maybe, yes, sure. Yeah, let's fix this.
I have video evidence, okay.
Okay, okay. We'll fix it with the math, right? In the same way.
That's
we just
what
remap
I was
it.
gonna suggest.
Yeah, we're just gonna remap everything to what?
Nice, cool.
Yeah, and now let's see how they outline. Hey, look at that.
Oh
right.
Man, these are so satisfying.
Yeah. All right, now let's do bounce check.
Hell yeah, bounce check.
What does it mean? Let's talk it through. Annotate.
This is like science.
Boom. Here's your boundary.
Nice. That was a straight fucking line. Get that thing zoom.
And then here's your particle.
Yeah.
Right?
Yeah.
And you want this to bounce like this.
Yeah.
Right?
Yes.
How do we do this? Well, actually, all we need to do is to change the, so this is like the normal towards our boundary, right? So this is the right angle.
Mm-hmm.
Make sense?
Mm-hmm.
We know that this angle equals to this angle. The only difference between these two vectors is their corresponding coordinate of this vector is flipped. So your red vector is defined with some values, right?
Mm-hmm.
X1, Y1, Z1. And then say the vertical, it hits the boundary on the x-axis, right?
Mm-hmm.
all we need to do for the green vector is to flip the x. So it's going to be minus x1. And then the rest is going to be the same. But these vectors are of what? It's not a position, right? It's just speed. Because what happens on the boundary, speed vector, velocity vector gets mirrored against the boundary. And then the rest will be taken care of because we calculate our position based on the velocity vector. So we don't have to worry about like clamping the position value or anything like that. All we need to worry about is how we adjust our speed. So let's create a function, right? So this function will take our current velocity, XYZ, and it will take our bounds as arguments. You mean bounds, you max bounds. Well, it actually also need to take the position. Well, let's do it after we updated our position here. So we're gonna pass new position. So we're gonna check for the position, right? Because velocity doesn't have coordinate, it has the direction, but position has coordinates. So we're going to check for the position. If this position updated on previous step goes outside the bounds, we need to mirror, reflect the velocity. So here's our function, check bounds, that takes vec3. So this is a return value, vec3. It takes position, takes vec3 of a bounds, it's mean bounds, vec3 of max bounds, and also takes velocity, vec3 of velocity. Don't forget here, when we call, specify that we only need vec3 on the bounds, because our bounds are vec4 right now, right? What we're going to do, we're going to check component by component. So first, we're going to say if position x is more than max bounds x, or position x is less than mean bounds x, then we're going to call new velocity, or we can actually modify the existing one, velocity x equals minus velocity x, right? So if it hits the vertical boundary, right, we just mirror it back. And then we're going to do the same for two other components. This is for y, and for z. All right, so here we have new velocity, right? We check for bounds, it returns new velocity. Now, what do we need to do? Because we already applied, at this step, we already applied velocity, right? We get velocity from here. We already applied it, right? And then we check new position. We calculate new velocity, right? It might be updated. So how do we use it on the next step, next iteration, next frame? It's the same idea with the position. We need to save this value for the next cook. Where do you save it? It's the same idea why we use these guys.
Do you have to use feedback again?
Yeah.
Yeah.
How do we do this if we have just one texture buffer and we already save in the position in there? Like GLSL here only has one output. This is what your render select is calling color buffer, right? And there is an index. So your shader can actually output multiple buffers. It's like, think of it as a 3D texture. Right now, when we do frag color, right, by default, it outputs to the first color buffer. Yeah, the first one, or like the one that has index 0, and the one that we see here in the preview, right? But there is a way to specify multiple color buffers, output color buffers. The way you do it is, I don't remember. Layout, yes, there you go. Thank you very much. Layouts, location 0 is gonna be new pause, and this is going to be new velocity with location 1. So here we're going to call new pause equals our new pause and new velocity. Oh, we already calculated it, so we didn't have to do it. We're going to just move it here so it's clean and organized. Well, yeah, let's actually do this. Like 3, check velocity, because we need to do this TD output swizzle on the result. TD output swizzle, and I don't want to overload the code with function calls. Your shader computes new position, right? It outputs new position, and then you need to take this output to the input of the shader. What do you use for that? Feedback. Now your shader outputs position and it outputs velocity. It's just in different color buffers. You get position back through render select and a feedback. And the same way you get your velocity back through the render select and a feedback. You just specify a different index for the render select. But we're going to have the similar setup for the velocity. We ask for the velocity buffer here, out val.
Out pause and out val, okay.
I never like checked val. We call it new val.
Okay.
New val, and then here we're going to do out val and out pause. That's it.
Wow, look, it moves. It's so slurmy. And it stays.
Yeah.
This is so fun and cool. Wow, look at it go.
Yeah.
Jeez,
all right,
man.
good.
Math is awesome. Wow.
One thing that I like to do, a little optimization here. Just drop a text. We're going to call it reset feedbacks. Boom.
You don't want to just do
and
a button?
Here we're going to do
the button to the pulses?
No.
Why?
Because it doesn't work always, but I know the script will always work. Right. We're going to tie the pulse and button later to the script. Yes, but first we need to build the script.
That's terrible.
Back, right? No, you trust me. I've been there.
Okay, Dedushka, I trust you.
Yeah, feedback bar, reset, pulse, boom. And now every time you do command R, and this thing it executes. Yeah. You will make button upstairs, right? Well, probably you will make the pulse on your base parameters of your GPU particles system, right? And then whoever uses your particles will make a button. The problem with this is with the pulse and trigger thing is that it can be skipped. It doesn't always trigger. Just do this. Do it in a loop.
Oh, right. Oh, that's really pretty. I like that a lot. Okay, stand by. Because I put fucking semicolons because this is Python and that makes any sense. Okay, do it. Yeah. Oh, that's so. That's smart. I like it a lot. All right.
What do you like?
It's just the loop. I like the loop. The loop makes me happy.
Oh, if you like the loop, okay, let's go back to the shader.
Yeah, show me the
make
shader.
You a loop. Because this is ugly.
A loop.
So I'll do this.
Oh.
All right, we're gonna iterate instead of writing these if statements 3 times. We're gonna iterate through every component, right? So instead of this, we're gonna write if our pause if component more than max bounds if component, or pause if component less than min bounds if component. Then we're gonna flip the if component of the velocity. Right? And then we're gonna delete all of this.
That's so fucking smart.
Beautiful.
Wow.
Magic of programming. Let's see if it works. Yeah, it still works.
Oh my God, it's so pretty. This is crazy, bro.
Yeah, it's every time I do this, it's like, oh shit, hold me. Anyhow, well, usually the way to spot these optimizations
when you have multiple
is when
copies
you
of the same thing.
Yeah, when you see this in programming, they code smells. When your code smells, you know, like
code smells
bad, you can clean it up. So we have bounds now, right? How does it feel for you? Like, how do you feel about this render select feedback? Does it make sense?
It's so cool. It makes a lot of sense.
That's the main trick that you use to pass the whatever calculation you make in your shader, and then you need to pass it over back to your shader to like iterate on it. That's what you do. Like you specify if you need more than one buffer, you specify different layouts.
It's so pretty.
You specify layouts here, right? And then you use render selects to access these layouts, and then you use feedback to pass the value again to your shader. So now what happens is that our position is being constantly updated. Our velocity is being constantly checked and updated. What we don't like about this thing is that they move constantly, right? They never stop. And we wanna control this. You probably heard about drag in particles. So let's implement this. In our inputs, let's assume that the second component will be drag. Drag values go from 0 to 1, which represents 0 means no drag. So if the drag will be 0, we will see something like this. So it never stops. And if it's 1, it will stop immediately. Let's set it to 0.1. And let's go back to our shader. On top of our shader, where we extract our values, we gotta extract our drag from the first component.
Okay.
So what does this drag mean? It just means that your velocity on every iteration is being decreased by this value. So after we check our velocity for the bounds, we decrease our velocity. So it's going to be multiplied by this drag. And I usually do divided by FPS. It needs to be done because our shader executes each frame, and then number of frames in a second varies, depends on the load on your system, but you want to have your simulation to be deterministic. So no matter how many FPS you run, in 1 second, your calculations will be exactly the same, right? Whether you run at 10 FPS, 60, 120, or 30 FPS. Wait. Yeah, we need to 1 minus drag. I think this should work.
Yeah, slow down. Cool. Physics.
One thing that we can also add to our simulation is when it bounds, the velocity might be also decreased. Could be a cute little feature.
Cute little feature.
So yeah, let's do that. So in our inputs, the third component is going to be damping, bounce damping. So you can set it to 0.1. So if damp is 1, then the particle will stop at the bounds. So the damping is next, right? So let's go back here. You know, shader. Unpack our bounds damping. And then we're going to pass it to our check bounds function. It's the last component. Bounds damping. We're going to damp velocity only when it bounds. Okay, so again, this means that we need to multiply velocity by 1 minus bounds damping. Yeah, let's call it damp. Let's see what we have. Well, maybe so that it's visible, we can remove the drag. We set drag to 0, so they move constantly. And then we increase the damp and see how this effects. Do we notice that it's been dumped? Oh shit, yes, we do. Interesting. You know what?
What?
Interesting. Oh no, yeah, I see. I see
Does
what
it
I see. I see.
eventually
No, 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 no,
make
no,
it
no, no, no.
pop?
I fucked up. No.
Okay.
Yeah, I'm stupid. We need to do this here.
Oh.
Right, we need to multiply all components, while here
Yeah.
we will multiply just one of them.
Each one, yeah.
Yes. Wait, damp is 1 means it stays there, right? So it has to be 1 minus bounce damp. Yeah, there you go. So check if damp is 1, then they're gonna be stuck at the boundaries. Yeah, it's sticky. Look at that. Ding. Damp is not 1. It's gonna be this. Eventually it's gonna land on the boundaries because we have no drag right now. If we introduce drag, we'll run it. Oh, you know what might be actually interesting?
What?
Is the negative damping. Let's see if we have big drag and negative bouncing. What happens? Look, some of the particles are going crazy.
That's cool.
Not really.
I'm stupid. Thanks, Delushka.
You're welcome. If you like cute things in the code, then do this.
I do.
If bounce, then you can return velocity multiplied by this value. Otherwise, you're going to return velocity. Do you know this operator?
No.
Now you
That's
know.
so cool. Wait. Stay. If bounce goes to I love coding.
The operator is like, it looks like this condition, question mark, if true, colon, if false, right?
That's so dope, dude. Okay, wait.
Yeah.
So
if true and if false should be variables.
Okay.
Right.
Return.
And they should be of the same type.
That's so dope, dude. All right.
Okay. Next thing that we want to do is we gonna change color based on speed of the particle. How the hell do we do this? Our velocity is, it needs to be passed to our vertex shader. So we're gonna add a sampler as velocity, and we're gonna specify this guy, velocity. And we're gonna go inside, add uniform sample. So we're going to use the same logic here to extract the values for the velocity.
And I guess the column and row, that can all be the same, huh?
Yeah, exactly the same. So now the idea is that we're going to have a palette, right? We're going to replace it later with the ramp, but for now we have, like, say on the left side we have blue, on the right side we have red color, and then velocity equals 0 will be blue and maximum velocity will be red. What is the maximum velocity? We know that the maximum velocity vector
is the length of the vector.
Length of the vector where each component is 1, right? Because we generate our velocity through noise, which is clamped at 1, 1, 1. So this is going to be our max velocity. Now we can get ratio. So we're going to calculate the current velocity, length of it, over max velocity. There is a function called, I think it's called mix, which takes left boundary, which is going to be our blue color, RGB, right boundary, which is going to be our red color, and then the like a progress bar between these two values. Ratio equals 1 will give us red, ratio equals 0 going to give us blue, and anything else will give us something in between. I
Does it need to be a
believe.
VEC4 though? Because if it's color,
Ah, you mean, well,
then you
yeah,
output
okay.
it, doesn't it?
Yeah, okay, well, yeah. That
Yeah,
makes
okay,
sense.
well.
Sure. No, yeah, that makes sense. All right, and then we provide this color here in this line. In the output vertex, we specify the color.
It works.
Yeah.
Wow.
It's crazy.
It's crazy, man. Mine keep getting stuck on the edges though. I fucking hate it.
Yeah, me too. I'm gonna remove the bounce.
Wow. Lots of jitters. All the jitters. After like 1 second of motion.
Wait, what?
You see?
No.
Oh?
Some of them, right?
Yeah. Not all of them, just the ones that hit the edge. They go bum 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 bum. Like watch the top.
Right. Yeah, I see. No.
No.
Wait. Interesting. I can't reproduce it. And your
Good.
bounce damping is
It's
0.
0. Yeah. It's just happening at the top. Like it's not happening on any other edge. It's just the top.
What? Just thinking why it would happen. It would happen in oh wait, what's your FPS?
Oh, right now it's 17.
I just set my TouchDesigner to 17.
No, it's 20, 23, 20, it's 20, 19, 17. It's
Does it happen
16.
often, this jittering?
Yeah, it happens.
Oh yeah, got it.
You got it? What is it? What'd you do?
Yeah. It's FPS. So the idea is that, no, it's not FPS. It's we fucked up. We're gonna fix it. It's good.
We fucked up.
Yes. It's a good catch. So
Yay.
the thing is that, look at the check bounce formula, right? We apply this formula, this function, after we updated the position. So it checks for the position, but it changes the velocity, direction of the velocity, right?
Mm-hmm.
What if your velocity is super small? So your particle is moving really slowly. So we calculate new position with the old velocity. This new position is outside the bounds.
Mm-hmm.
We flip the velocity. We apply drag to this velocity so it becomes smaller. Now our position is still outside the bounds because we don't touch the position. But we know we flip the velocity. So on the next frame,
we check the position again. It's still wrong, and we flip again.
Yeah. So we update the outside the bounds position with the new velocity, with the velocity that we have. And this velocity is just very small, is not enough to get it back to the inside the bounds, right? So yeah, we check it, it's still outside the bounds, so we flip it again, right?
All right, how do we fix it?
One solution, so we either have to check bounds before we update the position, or we do the same what we do right now, but we update the position. If it's outside, we put it on the boundary.
Got it.
So I think better approach is to do it before. So let's see, so this is the new position, right? Basically, if U velocity has changed, right? If there is if new pose outside the boundaries, we're not going to update it. So it's going to be the original one. And we apply the new velocity, drag, and then that's it, right? Don't update it. Boom. I think it should help. Let's see. You know what? Not updating is not cool. I don't really like that we skip a frame. That's not
Okay.
cool. You never skip a frame, right?
No, never skip frames.
You use all your frames.
Use all your frames.
So what do we do? I believe there has to be a function that will allow us to find the exact position on the boundary.
Whoa.
Because if you look closely, you'll
Mhm.
see how in cases when it skips the frame,
Mhm.
triangle gets like stuck for a frame at the boundary. For a frame, like it's not really smooth bounce now. It's like it goes there, like got stuck for one frame and then goes back. Set your TouchDesigner to 17 frames, 17 FPS, it will be more noticeable. I bet if you put it to like 8, it will be even more noticeable. Yeah, put it to 8. It approaches the boundary and then like stops there and then goes back.
Oh yeah, I see that. It's like no,
Yeah. Yeah.
It's like yeah, that's not
So
cool. It's not very slurmy.
yeah. So what shall we do with this? We gonna update the position. So our new pause is outside boundaries. Though we don't know which boundary, what we need to do is if there is a vector, so our particle moved from original position to new pause. Just happens that this one is inside while this one is outside. This means that somewhere in here there will be boundary. Look at all this infographic, huh? Crazy,
You're a
man.
graphic designer. That's crazy.
So this is going to be boundary. So we need to just find this position. Honestly, I'm tired.
Me too.
Let's keep it for next time.
Yay! Next episode.
Yeah, it's been like what? Oh shit, 3 hours.
That's
a lot.
We're nerds. Did you know? Wow. Okay, so what's your wrap-up statement? You gotta have a wrap-up statement.
Wrap-up statement.
Mm-hmm.
I don't know. Like use hand sanitizer often.
About the particles. Do you have a wrap-up statement?
Yeah. Particles. Yeah, particles are all right. You can use them in your projects and whatnot. They're cool. They're cool. Yeah.
Great. Particles
Jesus.
are cool. Trademark.
I'm tired.
Okay. Until next episode.
Next episode. Yeah, this is like 3 hours, 20 minutes.
Yeah. Tune in next time for 3 more
crazy,
hours
man.
and 20 more minutes of us making cool stuff and usually looking things up.
Can you make it in a series of TikTok videos?